So here we have placed a V stand, and on that V stand a concave mirror, and we placed an object here. We placed an object here, and the rays from this object will fall on that mirror, and it converges the rays to a point on the screen. So where does the screen should be placed? We should decide by moving it forward and backward. Okay, so where we get the clear image, and that is the image point. And if we change the object position, and the image position also will be changed in front of the concave mirror. Okay, so when the object is at infinity distance, that means sun, then the image will be formed at focus. So when the object is at infinity distance, and the image will be formed at a focal point. Then when the object is nearer to the mirror, then what would be happened? When the object comes closer to the mirror, then where the image will be formed. Yes, as the object moves away from the mirror, for different positions of the object, what is the different position, what is the perfect position of positions of the image? Yes, so that should be known. So to know that, if you want to know that perfectly, yes, so we should do that activity always, but it is impossible to do the activity always. Ante ఇమేజ్ ఆబ్జెక్ట్ ఎక్కడెక్కడ పెడితే ఇమేజ్ మనకి ఎక్కడ ఫామ్ అవుతుంది అనేది మనకు పర్ఫెక్ట్గా తెలుసుకోవాలంటే ప్రతిసారి యాక్టివిటీ చేయడం మనకి వీలు పడదు. Yes, we cannot do that activity always. For every time we cannot do that activity. So that is why we should follow some rules. So we have some rules. That means we have some representative rays. We have some representative rays to find out the image position based on the object position. Object ఏ పొజిషన్లో పెట్టినా, ఈ రిప్రజెంటేటివ్ రేస్ ని యూజ్ చేసి ఇమేజ్ పొజిషన్ ఎక్కడ ఉంటుంది, సో ఇమేజ్ నేచర్ ఎలా ఉంటుంది, అది ఎలాంటి ఇమేజ్, వాట్ ఇస్ ద నేచర్ ఆఫ్ ద ఇమేజ్ అండ్ వాట్ ఇస్ ద పొజిషన్ ఆఫ్ ద ఇమేజ్ can be found out using this representative rays. So let us learn the representative rays to find out the image positions based on the object positions in case of concave mirrors. Okay, let us see the first ray 1. So this is the concave mirror. Yes, and I'm drawing just principal axis, and here pole should be represented, and center of curvature and focal point. Yes, it is must. This representation is must in every diagram. Okay, so that is the concave mirror. It's silvering. Yes, that should not be forgotten. And next, principal axis. On the principal axis we should represent pole, center of curvature and focus. Okay, let us take the first representative ray, that is the ray which is parallel to the principal axis. The ray which is parallel to the principal axis. Okay, so if you draw the normal here, so this will become the normal at this point, right? Yes, so this is the ray which is parallel to the principal axis. After reflection it passes through the focus. It is a rule. It is the first rule or first ray. Yes, when a ray passes parallel to the principal axis, after reflection it must pass through the focus. It is ray 1. Okay, and coming to ray 2, here the pole, principal axis, center of curvature, focal point or focus. And next, second ray, what is the second ray we can take? A ray which is passing through the focus. It shouldn't be curved, it should be straighter, right? So a ray which is passing through the focus, and here also we can draw the normal for this point, and after reflection it passes parallel to the principal axis. These two rays are antagonistic to each other. That means it is a conserved rule for this one, so it's a converse rule for this one. That means a ray which is parallel to the principal axis, after reflection it passes through the focus. Here a ray which is passing through the focus, after reflection it passes parallel to the principal axis. And next, another ray, let us take this one here, pole, principal axis, center of curvature, focus, then the ray, the next ray, the third ray, let us take, which is passing through the ray 3, let us take the ray 3. So here the concave mirror, principal axis, center of curvature, focus and pole. And let us take another ray, the third ray, which is passing through the center of curvature. The ray which is passing through the center of curvature. Now look at this. Here the ray is passing through the center of curvature. That means a line which is drawn from the center of curvature to any point on the mirror act as normal. Yes, as of our knowledge that when a ray is passing from a ray, when a line is drawn from center of curvature to any point on the mirror, that acts as a normal. Now the ray is passing along the normal, right? Along the normal, that means so the center of curvature to the mirror, a point on the mirror. Yes, it doesn't deviate. Yes, the rays which are passing along the principal axis and the rays which are passing along the normals, they do not deviate. They do not deviate. That means just it falls like this, it hits the mirror here and it reflects back. It reflects back in the same path. It reflects back in the same path. It doesn't deviate. Yes, that means it retraces the same path. It retraces the same path. That means it is tracing one path, and after reflection it retraces that path itself, right? Yes, so when the ray is passing through the center of curvature, after reflection it retraces the same path. Yes, so these are the three representative rays. These are the three rays we have, and these three rays are the representative rays which are used to construct the ray diagrams of concave mirror. Ray diagrams of concave mirror. Okay, let us see the ray diagrams of concave mirror. Ray diagrams in case of concave mirrors. Concave mirror. Okay, let us see the first case. Let us see the first case or the first scenario where when the object is beyond the center of curvature, beyond C. When the object is beyond the center of curvature, beyond means just behind. Yes, center of curvature ki venakala, right? So object center of curvature ki venakala unnappudu image ekkada form avutundi, elanti image form aitundi. Yes, that is what we should know now, right? So let us take the concave mirror. Let us take the concave mirror. Yes, silhouette it and let us represent all the points, right? Represent all the points: pole, center of curvature and focal point, right? So let us take the object now. So object is beyond center of curvature. Yes, object is just beyond the center of curvature. Represent the object O dash. Object is represented as O dash. Yes, let us take, we have to take any two of these rays. It is not needed to take all the rays. Yes, any two rays we should take. To construct the image position and the nature of the image. Okay, so let us take the ray 1 and ray 2 in this case. Ray 1 and ray 2. Okay, what is the ray 1? A ray which is parallel to the principal axis. Yes, after reflection it passes through the focus. And that is the first ray, right? Yes, simple, completed. Yes, next, second ray. Yes, a ray which is passing through the focus. Yes, a ray which is passing through the focus. This is the ray 1. Yes, and the second ray we should take a ray which is passing through the focus. Then after reflection it passes parallel to the principal axis. Yes, Completed. The diagram is finished. Now here, these two reflected rays, just at the time of finding focal point, I said, yes, where all the reflected rays meet together, that point will be the image point. Yes, there the bright image will be formed. Here also, in this case, here the two rays, it is the ray 1 and it is the ray 2. It is incident ray, it is incident ray, it is incident ray. It is reflected ray and it is also a reflected ray. These two reflected rays have met here. Yes, they are intersecting that at that point. That means these rays are intersecting at this point, means these two rays are coming from the tip of this object, that is O dash. Yes, from O dash we are getting these two rays. Yes, and these will form the image of this O dash. The tip will be formed here. The tip will be formed here, right? Yes, so that will be represented as I dash. Yes, and next the rays from here, they come here like this and they reflect back, and here the image will be formed. The total image will be formed here. Yes, because here the reflected rays are meeting together. That means it will be the image position, that is I dash. Here it is I. So what is the image and what is the object here? O dash is the object which is placed in front of the concave mirror, that is B and center of curvature, and I dash is the image position. I dash is the image position. Where it is formed? It is between F and C. It is between F and C. That means focus and center of curvature. Yes, with this what we can say, when the object is placed beyond center of curvature of a concave mirror, an image will be formed in between focus and center of curvature. Then what is the nature of image? Image form in a place low, but elant image adi. So what is the nature of that image? Yes, let's see. This is erect image. It is the object, normal object. Yes, it is normally, that is the erect one. Yes, so straight object we placed, and then here it is upside down or straight. Upside down image is formed. Then how can we term that upside down image? Inverted image. Inverted image. And the image, already I said that when we placed in case of finding focal point, I said that we placed the mirror in front of window. Yes, and screen also placed. On the screen we observed the image of the tree. On the screen we observed the image of the tree. That means the image is formed on the screen and that is inverted. Yes, the image which can be caught, which can be obtained on the screen is called as a real image. Yes, and in case of convex mirrors, what we have seen, the same tree image is formed inside the mirror, right? So the images which cannot be caught on screen or which cannot be taken on screen are called as virtual images, right? The images are here two types, right? Remember, images are two types: real image, virtual image. Real image can be taken on screen. Virtual image cannot be taken on screen but can be seen only in the mirror itself, right? So here the image is taken on screen. This image will be formed on screen. So this is real image. So what is the nature of image now? Nature of image. First, it is real image. Yes, it can be taken on screen. Real image. And next, it is inverted image, upside down image. Upside down, it is not straight. Yes, and next, if it is its size, what about the size of the image when compared to the object? Then the object it is smaller in size or larger in size. Yes, that we should observe. Yes, here the size will be lesser than the object. Lesser than the object. That means diminished image will be formed. Diminished image will be formed. That means lesser size containing image, that is diminished image. Diminished image. And where it is formed now? Between F and C. Between focus and center of curvature. So when the object is placed B and C in front of a concave mirror, a real, inverted, diminished image will be formed between focus and center of curvature of that mirror, right? It is the first scenario, yes, in case of the ray diagrams of concave mirrors. And let us see the next one, next situation. Let us see the next situation, that is the second situation, when the object is at center of curvature. Object is at center of curvature. Yes, let us take the same diagram again. Concave mirror, principal axis pole, center of curvature, focus. Yes, and now where is the object? Object is at a center of curvature. Let us place the object at a center of curvature and represent it O dash. These representations are very important. Yes. Next, let us take the rays. Which rays? The representative rays, the same, ray 1 and ray 2. Let us take the ray 1, a ray which is passing parallel to the principal axis, and after reflection passes through the focus, yes. Then the ray which is passing through the focus, after reflection it passes parallel to the principal axis, and where the image is formed? The image is formed at C itself. The image is formed at C, right? So here this is the image point, which is I dash and I dash is the image point here, right? I've taken the same two rays. This is the ray 1 and this is the ray 2. Yes, these two rays are fallen here and the reflected rays met at this point. Yes, at C itself. Yes, so here what happened here? The same sized image will be formed here. So let us write the nature. First, real, as usually it is a real image, can be taken on screen itself. Yes, and next here inverted image, upside down image. These two are same. Inverted image, and next is inverted image, then diminished or enlarged or same sized image. Object కంటే చిన్నగా ఉంటుందా, పెద్దగా ఉంటుందా, ఆబ్జెక్ట్ ఎంత సైజ్ ఉందో అంతే ఉంటుందా? Okay, so here in this case the same sized image will be formed. Same sized image will be formed here. Same sized, and where it is formed? At C itself. Okay, when the object is placed at center of curvature of a concave mirror, a real inverted same sized image will be formed at C. Yes, so from this point, from this scenario, we can state a statement. We can say a statement. Yes, to get the image on the object itself, where the object should be placed in front of a concave mirror. This is the question. Yes, to get the image on the object itself, yes, where the object should be placed in case of concave mirror. Image ni object painane తీసుకురావాలంటే ఆబ్జెక్ట్ ని కాన్కేవ్ మిర్రర్ ముందు ఎక్కడ పెట్టాలి, ఎక్కడ ఉంచాలి? Yes, where it should be placed? Just on the center of curvature, at the center of curvature. Yes, so here to get the image at the center of curvature itself, we should place the object at center of curvature, right? So it is the second case when the object is at a center of curvature. And let us go for the next, that is when the object is in between focus and center of curvature. Yes, first we place the object beyond center of curvature and we moved it forward. That means at C we placed. Now we are going to place the object between F and C. Let us see what would be happened. Okay, let's take the same concave mirror, principal axis, pole, focus, center of curvature. Yes, and I place the object between focus and center of curvature. Yes, represent the object as O dash. And let us take the first ray which is parallel to the principal axis. Yes, it's a ray 1. Ray 1 I have taken, and after reflection it passes through the focus. Yes, and let us take the ray 2. Can we draw the ray 2? Yes, we can draw the ray 2. Yes. So ray 2, it is passing through the focus, and after reflection it passes parallel. It passes parallel to the principal axis. Passes parallel to the principal axis. Then it is these two rays are meeting at this point, and this point will be the image point, that is I dash, and here it will be the total object, like this I dash. Yes. Now how can we write? Yes, when the object is placed between F and C. Object is in between F and C. Then what happened where the image is formed? It is C, B and C. So let us see the nature of the image. It is real image, that can be taken on screen. Yes, real, inverted, definitely it is inverted upside down image. And next, it is a diminished image or enlarged image. It is enlarged image. Enlarged image, the size of the image is more when compared to the size of the object. So enlarged image. Enlarged image. And where it is formed, what is the position of the image now? Yes, image is formed beyond center of curvature. So beyond C, the image is formed beyond C. So when the object is placed between F and C, image is formed beyond C, and it is real, inverted and enlarged. Yes, so this is such a case. And next, in the last situation, that is when the object is in between P and F. Okay, let us see another one. When the object is at focus, let us see. When the object is at focus, let us see. Yes, the concave mirror, pole, focus, center of curvature. Yes, when the object is placed at a focal point. Yes, now the object is moved just nearer to the mirror. Yes, first we placed B and center of curvature, then C, between F and C, now at F. Yes, let us take the ray, first ray, the ray 1, which is parallel to the principal axis. Yes, after reflection it passes through the focus. Yes, the first ray is constructed, is no problem. Can we construct the second ray? Ray 2 can construct here. The ray should pass through the focus. It is impossible. It is impossible. So for that, we should take another ray. Yes, the ray which is passing through the center of curvature. The ray passing through the center of curvature. Yes, just like this. Center of curvature ikkada undi kada sir, ella veltundi? That is not the case. Yes, so ikkada nundi ila teeskunte manaki ray ila veltundi annamata. Yes, ఆబ్జెక్ట్ నుండి ఈ డైరెక్షన్లో, ఆబ్జెక్ట్ నుంచి ఈ డైరెక్షన్లో వెళ్తుంది కాబట్టి మళ్ళీ రిఫ్లెక్ట్ అయిపోయి yes it retraces the same path. Yes, it retraces the same path just like this. In that manner we have to construct. Yes, so now if you see this, it is a reflected ray and this is the reflected ray. It is the incident ray. ఈ ఆబ్జెక్ట్ నుండి ఈ టిప్ నుండి రే అనేది ఇలా వెళ్ళింది, వెళ్ళి ఇక్కడ ఇన్సిడెంట్ అయి ఇక్కడ ఉండే మళ్ళీ రిఫ్లెక్ట్ అయిపోయింది. సో ఇది రిఫ్లెక్టెడ్ రే. Yes, it is the incident ray as well as it's a reflected ray, right? So these two reflected rays, are they going to meet at any place? These two rays are parallel to each other, right? These two reflected rays are parallel to each other. If the two reflected rays meet together, then we can get the image, right? But these two reflected rays are not, they don't seem to be met at a point. Yes, so those are parallel to each other, they may go like that. Yes, they may go like that away, just far, whatever the place we can, whatever the distance we can see. That means the image might be formed at infinity. The image might be formed at infinity distance. Yes, is it clear about it? So when the object is at focus, the image will be formed at infinity that we cannot find. Yes, and the nature of the image cannot be defined. The nature of the image cannot be defined when the object is at focus. Is it clear? Yes. The next case, that is when the object is between P and F. Let us say this: pole, focus, center of curvature, and now the object should be, it is between P and F. Object O dash. It is between P and F. Let us take the first ray. Ray 1. After reflection, it passes through the focus. There is no problem. Yes. And let us take the second ray. It cannot be taken, and we should go for third ray. Third ray. That is, which is passing through the center of curvature. Now this is the reflected ray and it is the reflected ray. These both reflected rays, are they going to meet at any place? No, they are not seeming that, they are not observing that, they are not appearing that they are going to meet. Yes, those are diverging rays. Those are diverging rays. If you observe them properly, those are diverging rays. Those are not converging, those are not parallel. In the previous case, those are parallel, but here in this case, those are diverging. Yes, so there is no chance to form an image, right? So that is why let us look for the image inside the mirror. Yes, let's see that. Let's rub it. Okay. So if you extrapolate these rays, if you extrapolate the reflected rays, not the incident rays, it is the incident ray. I'm extrapolating or extending the reflected ray. This ray is extended. At the same time, this is the reflected ray, right? So it is also extended. So here the image is formed. Here these meet together. Right? What happened here? Enlarged image is formed, and it is formed inside the mirror. It is formed inside the mirror. Let us write the nature. Okay, now first, is it real or virtual? Is the image is real or virtual? So in this case, what happened? We have taken an object and placed it between pole and focus, and the two rays we have drawn, we have constructed the two rays, but the reflected rays of those two representative rays are diverging. So that is why on in front of the mirror there is no chance to form an image. So let us look for the image inside the mirror. Yes, inside the mirror are those reflecting rays. If we extend those reflecting rays, yes, are they meeting at a point or not? Yes, our side lo image form avvadaniki chance ledu. Ikkada image form avvadaniki chance unda ani chuste, ikkada reflect ayina rays ni manam extend cheste, ee reflect ayina rays manaki ekkada meet ayina ee place lo meet ayinayi. Ikkada meet ayinayi kabatti, intersect ayinayi kabatti ikkada image form avvadaniki manaki chances untayi, right? So the image will be formed inside the mirror, and let's see the nature here. So it is real or virtual. It is formed inside the mirror. We are not getting the image on screen. We didn't get the image on screen, right? Yes, the image is formed inside the mirror. Yes, it is virtual image. It is a virtual image. Virtual image, and it is inverted upside down image or erect image. That means straight image. The object lagane undi kada, right? So this is erect image. It is not inverted image, it is erect image. Virtual erect image. Yes. Next. virtual erect image, and it is enlarged or diminished or same sized. Enlarged image. So size of the image is more when compared to size of the object. Yes. So next it is enlarged image. Enlarged image, and where it is formed? Inside the mirror. Inside the mirror. So where it is formed? Inside the mirror. So when the object is placed in between pole and focus of a concave mirror, a virtual, erect and enlarged image will be formed inside the mirror. Yes. So up to now we have completed the ray diagrams of the concave mirrors for the different object positions. Yes, when we placed, first we placed the object beyond center of curvature, the next we placed at center of curvature, then between F and C, then at F, then now we placed between P and F. So in this total thing, as we compare the images, as the object is moving towards the mirror, image is moving away from the mirror. So that is the thing we can, that is a pattern we can observe here. Yes. So as we have, as far now we have completed the ray diagrams of concave mirrors based on the representative rays. And the next class we will learn the ray diagrams of convex mirror.